this is the first session, really, just to give you a bit of an introduction to the data that we've been using and we will talk about for the remainder of this afternoon. So we're looking at what types of data are available. So the outline for this bit is just a brief bit of background, and then I'll go on to talk about the all-cause mortality data, which is most of the sessions, then cause of death data just to finish off, and to be thinking about also predictive variables. So the predictive variables are the variables that we will use to identify groups of people that have different socioeconomic characteristics. And then the focus for this workshop, it's going to be looking at male and female mortality in England. And just as a starter for 10, so to speak, as we all know, mortality varies by socioeconomic group. So some groups in the population tend to have rather higher mortality rates, so that the poorer parts of the population, and then the wealthier groups within the population, the better educated groups, tend to have lower mortality. And then we also know that mortality varies by region, so as again is a sort of slightly stylized fact, there tends to be higher mortality in the north of England compared to the south of England. So by way of example, this chart, I mean, you don't need to dwell too much on the detail. We'll get a little bit more from Torsten in his session. But what we're looking at here is deprivation as a way of separating the population. So this is the whole of the national population divided up into deprivation deciles. And for both males and females in this chart, hopefully you can see the laser pointer, but up at the top you've got the standardized mortality for the most deprived group in the population, and then down at the bottom you have the least deprived. And what you can see is that there's a very big gap between the most deprived and the least deprived, and that's the case for both males and females. And that's for the 60 to 69 age group, and the picture looks rather similar for different age groups, but perhaps with differing levels of inequality between these different groups. And then something else that we're interested in, and I'm sure all of you are interested in as well, is that if you look from the sort of left and move towards the right, so that's 2001 up to 2016, then what you will see is that the gap between the most and the least deprived, that gap is gradually getting wider and wider as time has been going on. So levels of inequality have been getting bigger rather than getting smaller. And it's the same, very much the same picture for females. So that was by deprivation as a measure of socioeconomic status. We've also got these regional mortality rates. So we've used a sort of standard definition of there are 9 regions within England. So this map just gives you an idea of that. And with London being one of the 9 regions. And as we'll talk about later, that London does have its own peculiar characteristics and dynamics which are a bit different from the rest of the country. And so looking at mortality at the regional level, so what this table shows is we're looking at the males 60 to 69 age group, and we're looking at the actual deaths versus the expected deaths. Now, in this case, the expected deaths are calculated simply using the national mortality table, but then applying that national mortality to the population that we have in each region. So what we find is that in the northeast, the actual deaths are at 118% of what we would expect if everybody was exposed to the same rate of mortality, and then the southwest of England, it's down at 87%. So this is the basis of the so-called north-south divide, this type of table where if you just take the raw figures in terms of when people die, then that's the sort of typical picture that you get. with, again, similar variation north-south when you're looking at different age groups and also for females. But it's also worth noting that this comment down at the bottom is that regional variation that we see in this table, that is a lot less than the variation that we saw a couple of slides back where we had the deprivation deciles. So just summarizing that, so there's the first couple of points that we've talked about, but also, apart from the regional mortality, if you look at the geographical differences in a different way, what you can also see, I haven't put it up here, but what you will also see is that the mortality rates in the big cities tends to be also higher than the sort of national average. And again, that's because there is more deprivation in the bigger cities. So the sorts of things that we'll be thinking about later on this afternoon are how much of that variation can be explained by the underlying socioeconomic differences between the regions. So, as we know, there is more deprivation in the north of England, and so is that really the only driver of the differences between the north and the south, or is it something extra, which is in terms of regional variation? So is there something left over in terms of geographical variation? And for example, if there is, then that would be simply because of things like in the north of England or in other regions that there are perhaps just generally more smokers, or in another region of England that people might follow a worse diet compared to other areas, even after you take account of the socioeconomic differences. Now, how much data? So this is building up to the sort of main point of this introductory session, is to talk about the data. So how much do we have? And I've here sort of categorized it in three types. So there's the small data, which is the data that we used to work with as actuaries. So you just had the national table, you had your own pension plan perhaps, or your life insurance portfolio, and that was it. So you would, in terms of numbers of cells of data that you're working with, there's really not huge amounts. Just numbers of years times the number of ages that you're looking at. And then at the other end of the spectrum, you've got big data. And properly big data is, for example, the result of these things, the Fitbits and Garmins and so on, where it's really almost collecting data in real time, and then it gets sent off to some central server. And it's the type of data which cannot be properly processed, or can't at all be processed on a laptop or any desktop computer. So you need seriously big computing power in order to be able to handle that. And then what we have today is what I've therefore called medium data, somewhere in between. And the point is that, as I'll describe in the next few slides, is that we've got, instead of just up at the top, we just had the national population and then maybe one other population to look at, that we actually have data for a very large number of small geographical areas. And that's the sort of population counts and also deaths. But we will also have, for each of these small areas, we will have area-specific predictive variables, which will help us to use those as predictors for high or low mortality. And of course, it can all be done on a laptop rather than a mainframe. So first of all, I'll then start to introduce now the data. So we're going to be looking at England only. And the key geographical area is something that somebody in their wisdom gave the imaginative name of lower layer super output area. And I'll abbreviate that for the rest of the session to LSOA. So what are these? So these are, there are just under 33,000 of these small geographical areas across England. And the way that they're designed is that they're designed as sort of local neighborhoods, which are, as much as possible, within that area, they are intended to be socioeconomically homogeneous, so that everybody should have a similar sort of background within that area, as much as you can. just doing the numbers, so that means that on average there's about 1,600 people in one of these areas. Although it does vary quite a lot, so some of them are a bit less than 1,000, and then the largest ones are maybe about 3,000 people or so. So for the LSOAs, so we've, as I say, there are 33,000 of these. So for each one of those, we have deaths and exposures, or population counts. And we have data for single years and also single ages, and also by gender. So the indices for the deaths and the exposures then start to get slightly messy, if you want to think of it like that. So gender, I would be representing the LSOA, time and age. So that's the data set. So just for the data, the deaths and the exposures, we've already got a large data set compared to what we would maybe be used to. What we want to do is to think, well, can we, rather than just apply the national mortality rate to the deaths, to get expected deaths, can we use the predictive variables in order to get better predictions of high or low mortality? Now, so just before we get to the predictive variables, just beware of some of the challenges with these data. So because these are small geographical areas, that does mean then that a lot of the deaths are going to be zeros and ones, and in particular, 90% of the death counts in this large array are zeros. So that's fine if it just means that you need to use proper statistical distributions, and anything like a normal approximation is not going to work so well if you're looking at that level of detail. And then also about 6% of the exposures are also zero. So again, that should be fine. You just need to work carefully. However, for the exposures, I mean, the death count should be reasonably accurate in terms of the death records will identify where each individual lived, so they should be properly allocated to a particular LSOA as their normal place of residence. However, the exposures are estimates, so you'll get the best estimates in the census years, but equally you'll get sort of less accurate estimates in the intermediate years. And the data are returned as integers. Now, the issue then is that there is a very small number, but non-negligible number of cells where you have, say, 1 death and 0 exposures, which, of course, that's a problem if you just start doing the modeling without taking account of that. So there are different ways of handling that. So what we'll talk about is that if you're covering a number of years or a number of ages or both, then you get to larger numbers of exposures. I mean, you lose some of the detail, but you get to larger numbers, and so you don't end up with 1 death and 0 exposures. So just be aware of that if you're looking at this data. So now talking about the predictive variables, so the indices of deprivation, they're the sort of bedrock of what we've been using in terms of variables that you can use to predict high or low mortality. So there's the headline index, the index of multiple deprivation, but there are a number of domains that are within that, and things like income deprivation, etc. So I'll got a few more slides that will go into more detail with those. And then there are, outside of the indices of deprivation, there's a number of other predictive variables that you can, if you dig around for long enough on the Office for National Statistics, you will find these other bits of information. So all of these I'll describe in the coming slides. And then now there's a few more. And then down at the bottom, there are some other variables that are not specifically to do with socio-economic status, but they are going to be useful in terms of the predictions. So first of all, there's the LSOAs. So, I mean, I don't really need to go into particular detail here, but just very briefly, so the codes themselves, so all geographical areas within England, Wales, and Scotland have this type of code, and the first 3 digits, so the E is for England, O1, the 1 is saying it's referring to LSOA level, and then other digits other than 1 would be referring to things like local authorities or regions. So for our purposes, we're looking at LSOAs, so it's really only the last 5 digits that matter. And so the indices go up to 33,768. The reason that's bigger than the number of LSOAs, and the reason for that is that over time, the original set of LSOAs, some of those have been split into 2 because the area has grown through house building, for example. Other areas maybe have a shrinking population, and so you maybe have a merger of 2 LSOAs. And then alongside that, and it depends on what sorts of purposes you're thinking about, but as actuaries, some of your data sets might have postcode information. So there's a lookup file where you can map the individual's postcode into an LSOA, and then you can also then map into regions, for example. Now, the index of multiple deprivation, so the IMD itself is the official composite measure, and then it has these various subdomains that I'll talk about. And so all of these are perhaps useful in terms of predicting mortality. The one that we have specifically not included in our analysis is health deprivation, because that's already an indicator that people are already ill, whereas what we're really looking for is what are the other non-health related predictors that are predictive of high or low mortality. So the first of these is income deprivation, and this is one of the ones that's really the most important in terms of predicting high or low mortality. And this is really measuring within each of these LSOAs what proportion of the population have or are receiving benefits from the state because they are on a low income. So we just get one value for each LSOA. And then just the sort of last bullet is just mentioning that the main income deprivation index covers all ages, but then there's also a subdomain called the income deprivation affecting older people, and that's measuring income deprivation amongst the older age population. Next, there's employment deprivation, so that's measuring unemployment. So that's a different set of benefits, but clearly with a focus on the working age population. So in fact, what will happen later on in the last 2 or 3 talks is that we'll be using income for the elderly as one predictive variable, and then employment deprivation, because that will affect the younger population. And inevitably, there's quite a high correlation between these variables. Living environment deprivation, that's another of these domains, and what this is measuring is the quality of the living environment. Indoors, that's the quality of housing, so are houses modernized, do they have central heating, things like that. Air quality, traffic accidents. Barriers to housing and services, again, that's split also, so there are wider barriers which have overcrowding, homelessness, and the affordability of housing. And then geographical barriers is measuring the distance to key services like doctors, surgeries, shops, libraries, and things like that. But the interesting thing here is that although for the purposes of the deprivation indices, a sort of high value for geographical barriers, so that means bigger distances, so that means that they are deprived in that area. But if you're thinking about mortality, if you have to go a long way to get to the doctors or the library, etc., that may be because you live in a very affluent part of town with big gardens, etc., where you necessarily have to drive a few miles. And so, in fact, what we do find is that there's a negative correlation between life expectancy and this geographical barriers. Crime, measuring the risk of personal material victimization. And then we get on to other variables, so not the deprivation ones, but the average number of bedrooms, that's one. Highest level of qualification. So there's a version of education which is part of the indices of deprivation, but there's another data set which has a lot more detail. So we have different age groups. You also have 8 different education groups. So the data that you get that you can download will tell you how many people or what proportion have these different levels of qualifications, from no qualifications all the way up to bachelor's level and higher. And then there's a similar data set for occupation groups. So again, here there are many quite small age groups, and then, maybe it's on the next slide, 9 different occupation groups ranging from the higher managerial all the way down to routine occupations. And then, amusingly, in one group, never worked or full-time students. A different predictive variable is urban-rural classification. So we wouldn't necessarily have immediately thought about this as a predictive variable, but we did find that this was going to be quite useful. But typically, the conurbation group normally does include London just within the same grouping, so just all big conurbations. But again, what we found in our analyses was that London was distinct from, or had different characteristics from the other conurbations, so we have separated that out as a different category. And then regions and communal establishment. So again, because we're looking at these small geographical areas, it's going to make a difference to mortality if there is or is not a care home in a particular area. And so the communal establishments data that we have, but also separates out whether the nursing home, whether the care home has nursing or does not have nursing. Other things that in our data sets, proportion that are UK born, ethnic groups, religious groups, country of birth, average weekly income, and the proportion of the population that have that work at 49 hours per week or more. So there's just a lot of different things that you can, if you dig around, you can find all of these sorts of things. And then lastly, if there's a particular question in the 2011 census that's maybe not been covered by those, you can put in a user request, a request for data from the ONS that will do a head count from the last census. And how much detail you get is going to depend on how sensitive the ONS think the question is, and the answers that they might give back. Some of these things do vary over time, so the one thing we can look at is whether the IMD indices change, so the ranking of each of the 33,000 areas, so do they go up or down from one time to the next? So this is actually just very recently issued. So our data is based on IMD 2015, but there's one that was released last month, and the key thing here is that most LSOAs remain within the same decile. This is for the main IMD index, but there's a few LSOAs that drift up or down by mostly one decile, but there's a few more that might go plus or minus 2. And then in my mind, I mean, I think a lot of that variation is actually really just noise in the data rather than a genuine change in the socio-economic characteristics, although there are maybe some more distinct trends, such as in London, for example. I recently compared the IMD 2011 versus 2015, and there's a bit of a drift in London towards gentrification or sort of less deprivation compared to the rest of the country. Right, so in the couple of minutes that remain, I'm just going to give you a flavor of how these different predictive variables all compare with each other. So they're not independent of each other, of course. So if you get one measure of deprivation for one of the domains, then you'll also be likely to be deprived for a different domain. So I'm going to plot ranks rather than the underlying values. And by plotting ranks, you're just focusing on the dependencies between different pairs of predictive variables. And then the scatter plots are also colored by urban-rural group, because that's quite interesting in its own right. So this is the first example. So we're looking at the main index of multiple deprivation and then the income deprivation. So of course, income deprivation contributes a lot to the main index. So there is high correlation. But you can also see there's lots of blue dots, and that's the rural areas. So each dot is one LSOA. And so the blue dots are saying that in these rural areas that there is sort of lots of deprivation as such, but there's not so much in the way of income deprivation. So the rural people are deprived in other ways rather than having low incomes. This one is looking at income deprivation versus employment deprivation. Again, a high correlation. This is almost the same, but what's different here is that this is the income deprivation amongst the old versus the employment deprivation amongst the working age population. So the correlation here is not so high. And so in general terms, having lower correlation is perhaps better in terms of being able to get good predictions. Income deprivation old versus living environment, and then you've got lots of blues up there. So in the rural areas, you have perhaps generally low deprivation in terms of income, but you have lots of unmodernized houses, for example, out in the countryside. So that's why perhaps you've got a lot of blue up there. Income deprivation versus the wider barriers, so that's homelessness and affordability of housing. This is, again, income deprivation versus the geographical barriers. So the rural areas are way up there, up at the top, because you have to go a long way to get to the doctors. Bit of a no-brainer. Income deprivation old versus number of bedrooms, and again, some blue up there, which is indicating that people have bigger houses out in the countryside. Income deprivation versus the proportion with a high education. And what you can maybe see here is that you have these sort of orange dots, and these are London. So these are predominantly up in the top right, and that's indicating that London, although it has lots of deprivation, London also has lots of well-educated people compared to the rest of the country. And then a different one, the proportion of UK-born versus the proportion with a high level of education in the middle-aged working group. And here, there's a broad orange band for London on the left, so that's saying that in terms of relative to the rest of the country, so London has more people who are born outside of the UK, but these are also better educated people, whereas down in this corner, in the other conurbations, you have, in some areas, a low proportion of UK born, but also low education rather than high education. So it's rather different compared to London. And then lastly, just a very brief comment about cause of death data, but then I'll come back to that later on. So we're looking at cause of death data. So instead of all cause data up here, where we have lots of zeros and ones, and the ONS, our Office for National Statistics, are quite happy with that in terms of all cause data. So that's not considered to be invasive or sensitive data. But the same is not true for cause of death. So even though the individual is now dead, the information about an individual in terms of their cause of death, that could be considered sensitive or invasive for the surviving family members of that individual. So we now have, for this cause of death, we have death counts, but it is even more variables now, and that's by region, because we don't have the same level of detail at the LSOA level. All we have is by region and by income deprivation decile. So I'll come back to that later. So just a few questions that we're thinking about. So this is the first session. What are good stochastic mortality models for capturing differences? What are the most significant socioeconomic factors? What factors push mortality rates up and down at the geographical levels? Does it make a difference in terms of urban, rural? Once we've modeled out the socioeconomic effects, what's left in terms of regional mortality? How much inequality is there in mortality rates at different ages? So we'll find out about that. And then for cause of death questions, what is the difference between controllable and non-controllable risk factors or lifestyle? Well, the lifestyle factors are controllable, but there are other risk factors that push mortality up and down. What causes of death do have significant controllable risk factors? Which causes of death have significant levels of inequality. So what we're trying to do with this bit of and this is the final presentation today, we'll be looking at how does the inequalities here, how do they link to the inequalities that we will see at the all-cause level. And then, again, with the cause of death mortality, can we talk about which causes of death are contributed to the slowdown in mortality improvements.